Find all relative extrema using the second derivative test of the function. We got a trig function again. We got sine of x, cosine 2x. Again, we have an argument other than x. Might make this more interesting later on. Chain rule will be needed probably on all derivatives. And remember, and we have a closed interval 0 to pi. Remember, second derivative test. If f double prime of that critical number, specifically when the first derivative equals 0, is greater than 0, we have a relative min. When the second derivative evaluated at that critical number is less than 0, we have a relative max. Well, if the second derivative is greater than 0, means it's concave up, means you're going to have that valley. That's why we have a minimum. If it's concave down, the function is, because the second derivative is less than 0, we have that relative max. Well, this is driving what we need to do. Find the first derivative. Using the chain rule. Find the zeros of the first derivative. Okay, let's use our identity. Let's substitute in. 2 sine x cosine x is equal to sine 2x. Let's factor out a 2 cosine x. And we get 1 minus 2 sine x left over after we divide out. Zero product property. All right, divide by 2, we get 0 equals cosine x. Using our knowledge of the unit circle, cosine, which is the width, is 0 right here. So when you go along, be right here and right here. So x equals pi over 2, and then x equals 3 pi over 2 are when the first derivative equals 0. See if some more values occur. Subtract 1, divide by negative 2, and we get 1/2 equals sine x. Unit circle again. Sine is the height. When's the height? A half. Well, that'd be pi over 6. And then over here, positive half occurs again when x equals 5 pi over 6. So we have the first derivative equaling 0 for 4 values. Okay, now we need to find the second derivative. Okay, take our first derivative, would be negative 2 sine x, be minus 4 cosine x, cosine 2x I mean. Now we need to evaluate the second derivative at these 4 values to see if it's a relative max or min. So f double prime of pi over 2, and without a calculator, let's see what we can do. Sine pi over 2 for cosine of 2 times pi over 2. All right, negative 2 sine pi over 2, negative 2 times 1 minus 4 cosine of pi, that's negative 1. And we get negative 2 plus 4, which is 2. The second derivative is greater than 0, therefore relative min occurs at pi over 2. Okay, later on we'll get the points. Let's go 3 pi over 2. Evaluate. Sine of 3 pi over 2 would be negative 1. minus 4, 2's cancel, cosine 3 pi, negative 1, which equals 2 plus 4, which equals 6. The second derivative is positive, concave up, therefore we have a min. Second derivative, evaluate at the third value, which was pi over 6. Negative 2 sine pi over 6 is half, minus 4 pi over 3, cosine pi over 3 is half. That'd be negative 1 minus 2, which is negative 3. Second derivative is negative, means concave down, which means f of x has a maximum. And finally, f double prime, 5 pi over 6. Five pi over 6, still half. 5 pi over 3 would be half. 1 minus 2, negative 3, therefore maximum. All right, we know we have relative min, relative min, relative max, relative max. Let's actually find the heights. So f of pi over 6, let's keep in order. Pi over 2, sine pi over 2 is 1, cosine pi, negative 1, 2 minus 1, and so we have the point pi over 2, 1, which would be our min. F of 3 pi over 2, sine 3 pi over 2 is negative 1, cosine of 3 pi, negative 1, and we get negative 3. F of, I believe, let's see here, pi over 6 was next. So we have our two mins, now let's find our two maximum points. So f of 5 pi over 6, let's see what we get. Sine 5 pi over 6, 5 pi over 6 right here, so 1/2 plus cosine would be 5 pi over 3 then, 5 pi here. Okay, so we have a relative min at, let's get our points. We get pi over 2, 1, and let's say it was 3 pi over 2, comma, negative 3, because f prime x equals 0, and f double prime x was, let's check again, greater than 0. Minimums where concave up creates the valley. Relative max at these two values, pi over 6, 3/2, and 5 pi over 6, and 3/2, because f prime x equals 0, and f double prime x is less than 0.